This is Computer Science 455, Software Engineering, Spring of 2020, the 8th of June. Today is the last lecture of our class, so I'd like to congratulate everyone for having to take this class up to the last meeting. Okay, let's talk about deadlines. Um, your revised SAD will be accepted um, on finals day, the 10th of June for partial credit. So the lecture today, I will talk about software architecture and design, and I will talk about forward engineering, which is the normal way of deriving the design from uh, from the deployment diagram up to the low-level design and detailed design. And the other one, if you are starting or you are continuing a project, so you start from the source code, derive the class diagram, the low-level design and detailed design, all the way up to the deployment diagram. That's reverse engineering. All test reports have been distributed, and your um, uh, and the report tells you which test cases you failed. But I think up to this point, all the teams were able to um, pass the test report. That will be finals day also, deadline. So make sure QA team is uh, informed that you are ready for testing. The maintenance manual is also due on the finals day, the 10th of June. So to review you on the maintenance manual, I showed you this last time, a sample maintenance manual from 2018 called the Optimal State of Living. And here is the format of the maintenance manual. I want to see the file structures of all your sources and XML or Java code or PHP or MySQL files, and I want you to list the names and where they are located so that somebody taking over your project will know where are all the files. And of course, to go with uh, the files, what are the instructions to compile, build, and create the running executable module. So section 2 is all about instructions on how to compile, build, and create the executable module or the mobile app itself. This is section 3, which talk about the good things you have done that should be continued in your in the previous team. What you think is good, so that the next team will hopefully continue what you did as good implementation. And of course, there are kind of implementations that need improvement. So you will also list that here. So the next team will pay attention to the weak points in your current implementation. And the very last section is about overall recommendation. What do you recommend as the next step? uh, if some team will continue your work. Okay, so that's the maintenance manual, and QA testing and delivery of iteration number 2, prototype 2. As I said, deadline is the finals day. That's the 10th of June. Okay, so everything should be done by that particular day. I encourage that you try to finish earlier than the deadline, so you'll have a chance to fix any failure before the deadline. Okay, it's you don't know what are the test cases the QA team is going to use, and if you fail any of the test cases, you still have a time. You still have time to fix the error. Okay, so good luck on your prototype too. Um, I have just announced this yesterday about submitting a USB to me, which contains the following: the SRS, SPMP, SAD, source code, maintenance manual, and prepare a 15 to 20-minute video showing the features of your app. And I said in my announcement, um, the tradition in software engineering is to have an open exhibition, a public exhibition of your mobile app, and we invite uh, usually Esri, Optibus, Kelly Space alumni to come, and also the clients and their friends to the campus. Okay, so we have this in our repo, of course, but our repo is a tendency to disappear because we rent space on DigitalOcean, as you know, and we are also using another cloud facility called Azure for SOS. And so these are all uh, kind of temporary repo. As long as we are renting, we have it. So I'd like a more permanent place for the for our software artifacts, and that is the USB. Okay, I gave instructions on the how to get USB from me. I will supply the USBs, and then you'll return them to me by the 15th of June. That's a Monday. Now, Tuesday, which is the 16th of June, is when grades are due. So that will be the last date of um, giving me the USB. I'm reminding you that you are covered by the NDA that you have signed, so you are bound legally on keeping the information about the projects you did in this class to yourselves. The information should not um, get out of our class because of IP. There are intellectual property associated with the projects that you have. Okay? All right. So, moving on, as I said at the beginning, I'd like to review you again on software architecture and design. Let's talk about forward engineering. Okay, and I believe I discussed with you this example early on in the um, quarter, and here is the procedure on how to derive the high-level design the low-level design, and the detailed design. I called it forward engineering because you begin from the top and you proceed down to the bottom. So from high level to low level. This is typical in projects where you are starting the project. That means you are the developing team, the first team to develop. An example in our list of projects, iBox is a brand new project that is um, requested by physical facilities, and you are starting from scratch. There's nothing to build from because it is a brand new project. And so you begin in the SRS, if you remember, the deployment diagram. And in the deployment diagram, we specify components residing inside hardware. So the two-dimensional box here is a hardware. So you're beginning from the top and you're looking at the software components that you will need to reside in that hardware to actually implement your project. So you look at each software component and see if I can decompose it. Our famous divide and conquer or hierarchical decomposition will be used in decomposing this component into its parts, as you see here, subcomponents. So we look at B, and so from B, I figured, oh, I can partition or decompose B into two subcomponents. I'll call it B1 and B2. Okay? And then continue decomposing. So I look at B.1, see if I can decompose that. And indeed I can, okay? So B1 here was decomposed into a inheritance, as you see here, and another class called B.1.2. So these two, B.1 and B.2, came from this high-level definition of the component in the deployment diagram into these subcomponents. Okay? Using hierarchical decomposition of breaking up a big problem into its sub-problems. So the moment you are able to reach the class diagram, you are in low-level design. Okay? And if you still cannot decompose it into class diagram, you decompose it into further components. So keep decomposing into components until you can define each component or a particular component into each class diagram. Understand? So this is what we call forward engineering. You begin from the deployment diagram to the high-level design to the low-level design. Okay? And these are for projects where you are starting from scratch, like the iBox. iBox is a new project that Loma Linda Business Innovation Office likes to develop. Okay? All right. So do that. And the next step, you identify a specific class. And each class has functions, right? So it has functions. Let's say from F1 to Fn. You figured F2 and Fk are very important. They're critical functions. That means if they are implemented wrong, there could be a failure in your software. So what do? You um, write the pseudocode algorithm of F2. And we will use that later in design review to figure out if the logic is correct. And this will be the basis of your procedure on how to translate this into source code. Okay? So better find error on your pseudocode than find error in your source code, because the effort to debug a source code is 10 to 100 times more effort than to fixing pseudocode. Okay? So you select functions that are critical. And I define critical as those functions, if they are implemented wrong, your software could crash. Understood? Okay. So for forward engineering, again, I am emphasizing this. You begin from the deployment diagram to high-level design, to low-level design, to detailed design. Okay? Uh, I hope that is very clear, that you follow that procedure in deriving the high-level design, low-level design, and detailed design. Okay? All right, you're not done yet, because you have to decompose the other software module in your deployment diagram. So let's look at D. D is a software module or component, and you figured, oh, I think I can apply a three-tiered architecture here. So you're looking at the architecture style that we have studied before, and three-tiered is one of the most common architecture style that is used in software engineering. Okay, so you are also decomposing the problem, but not into its subcomponents, but you are using the three-tiered layered style of architecture. That means D3 is the lowest level of concern, D1 is the application level, and D2 is the middleware or the middle level of the three-tiered architecture. And problems or components can be decomposed into the three-tiered, and you actually identify the lowest level, the middle level, and the applications level. So you can choose whatever architecture style you see fit. This one here on this side, you're using hierarchical decomposition, and over here you are using layered architecture in decomposing this um, software component. Okay, and you also figure out now if this component E is a web server. Okay, if this is a web server, then the architecture style that is being used most commonly is the MVC. Remember, this is the Laravel um, design pattern that we use whenever we write web application. So supposing E is the web server, then I can use the MVC design pattern. So I use the architecture style MVC, as you see here. So use whatever architecture style that would suit solving the problem, okay, and apply that to your design. Okay, so all of these pictures here, B.1, B.2, MVC, uh, layered architecture, D.1, D.2, D.3, are high-level design that came out of the deployment diagram. Okay, and so from deployment diagram, I derive the high-level design, and from the high-level design, I derive the low-level design in class, and then from the class diagram, I derive the pseudocode of critical function. That's the procedure of the uh, software architecture and design. So you have here the overall picture. So the procedure is from, if you are doing forward engineering, that means you are the first team to start this project. Then your procedure must start from the deployment diagram to the high-level design to the low-level design, and finally, the detailed design. Okay? Remember that procedure. That's the only procedure I will accept for forward engineering. If you deviate from that procedure, I will not give you points for what you have submitted. Okay? So, uh, this is for a new project that you have started. So, you start from top to bottom. Okay? Top down. All right. So, let me um, talk about, let's talk about the reverse engineering. Now, reverse engineering is one where you are continuing a project. So there are uh, already source code that exists that you are continuing. So if you are continuing, you are doing reverse engineering. Now, here in the reverse engineering, if you are starting from source code, because source code is already there, I can draw the class diagram, right? You have the source code, I can draw the class diagram, right? So you're beginning from the bottom. From the source code, you write the class diagram associated with that source code. So let's say that we have the class diagram as drawn here. And then what you do is you look at the class diagram and see which class diagrams I can aggregate into a package. Which one of them? Well, according to cohesion, cohesion means class diagrams that are um, associated strongly with each other. Well, this is an inheritance diagram. So I would say, okay, they should belong together as a package. And since employee is kind of a customer or is a person, which could be a customer, then I could um, aggregate all this class diagram into one group. Okay, so here I drew a boundary over these classes together as one group. Okay, the by the name of the class, order and order line seems to be related to each other. Okay, because of the name itself. So I will group that into one. These two classes, I will group that together, and that will be one group. And the product is probably maybe outside of this boundary. So I have come up with three groups here according to cohesion principle. So in the next diagram, you will see that I have three packages, A, B, and C. So that's how I group together several classes together into packages. Okay, so from source code to class diagram, and from class diagram into packages. And the next thing that you should do is to replace this communication line between uh, between uh, packages like A and B has uh, a communication between A and B. So, and also from A to C, there is communication there too. So, I will replace those communication lines okay, pardon the silence. I have to plug my computer to a source or else I lose everything. But anyway, the communication lines is existing because of this previous diagram where you see here that this communication between these two packages is present. So I replace that with a single communication line. And then here you have a communication between this group and this group, package A to C. That's why they exist. Okay? And then I replace those communication lines with a ball and socket. Okay? The ball means I provide service to other packages, and the socket represents I need service from other packages. So according to the diagram above, A needs the service of B, and that C needs the service of A. That's the meaning of the ball and socket. Okay? And so once I reach this point, I have to find the relationship of that packages I have derived to the software components I have in the deployment diagram. How are those packages ABC relate to the software component I have drawn in my deployment diagram? Remember, the deployment diagram was drawn in the SRS. So you analyze each of these software component. What are they doing? What's the function? What's the goal of this software component? Okay, and so here is my analysis. After analysis, I think B.1 and B.2 let me go back to where I was. Let me show you that. Okay. B.1 and B.2, I analyze to be this a software component that I have drawn in my deployment diagram. So you figure out what functions B.1 and B.2 are doing is related to the B. And the D here, package, is related to this software component D. So uh, I derive that D is performing the function of this D component, and the B.1 and B.2 combined is doing the function of B in the deployment diagram. So you see here, it's different for the reverse engineering. In reverse engineering, you start with source code. And from source code, I derive the class diagram. See? From class diagram, I derive packages. And then from packages, I relate it to the software component of the deployment diagram. That's why it's called reverse engineering. You start from source code and you go up to the deployment diagram. Okay? Again, when I regrade your software architecture and design, there are only two procedures. If you're starting a project fresh, you are the first team to start that project, you should use forward engineering because there is no source code. You are analyzing the project from the beginning, from the deployment diagram. So you derive the high-level design from the deployment diagram, the low-level design from the high-level design, and the detailed design from the low-level design. I should be able to trace from deployment diagram all the way down to the function of a class. That's what I meant about tracing. Okay? If you didn't follow that procedure, I will not give you additional points on your SAD. Okay? Let's be clear about that. Okay? If you are continuing an existing project, you begin your procedure from the class diagram because source code is given. You reuse source code. So from source code, I can derive class diagram, right? From class diagram, I can derive packages, the high-level design. From high-level design, I can relate it to the deployment diagram. Okay? So if you didn't follow reverse engineering procedure, I will not give you additional points for your SAD. I should be able to trace from class diagram or from source code all the way up to the deployment diagram. If I cannot trace it where it came from, I will not grade your SAD. Okay? So I hope this lecture helped you in redoing your SAD. Okay? Let me give you another example of reverse engineering. So this reverse engineering is, let's say, Bubblin, okay? Bubblin, you guys are inheriting a lot of code from Chas and previous teams. So he has a lot of classes, he has a lot of files. Some files are for servers, some files are for web application, some are PHP files, some are database files, and other classes. So you're analyzing his work, okay? So there are lots of classes, I assume, classes and files and everything in that source code. So what you need to do is to find groups of classes and files that are related to each other using cohesion principle. Cohesion means if they are strongly related together, they're doing a common function, or they are collaborating to perform a function, group them into a cluster. And you will have clusters of packages. So let us say from this chaotic diagram that you see up here, you are able to find, let's say, 10 packages out of those numerous classes, files that you have grouped together. Let's say you came up with 10 packages. And of course, these communication lines here are the communication occurring between packages or classes when you group them. So they are represented here as dotted lines. Okay? All right. So let's say I group them. So, okay, this is the first group. These two packages are grouped together. These three packages were grouped together, and also keep in mind the different architecture style we have studied. The most common architecture style are the layered architecture. There is three-tiered, there's four-tiered, there's client server, there is repository, there is hierarchical decomposition, many others. So use that architecture style to group your packages. So here in this example, out of the 10 packages I have drawn, I have reduced it to 4 groups. See this? Okay, 4 groups. Okay, so once I put them together as a group, I come up with components. So this is the symbol for component. The first group, I call it A. The second group, B. The third group is C. And I replace communication lines with ball and socket. Ball, remember, provides service. Socket means I need the service. Okay, so that's how you draw the ball and socket. And these 4 packages under this group is further defined by replacing communication lines with ball and socket. So once I did that, I can represent these 4 packages into one software component. I'll call it B. Okay? So now you have to relate these 4 software components to the deployment diagram. Okay? So which one of those software component is involved in the function of the software component I have in my deployment diagram. Okay, all right. So this is what I do. I analyze the components that I have, and I say, oh, maybe A.1 and A.2 is fulfilling this software component A. Okay, and the E here is fulfilling the function of E here, and the D here is fulfilling the component B in the deployment diagram. So that's how I relate the deployment diagram to the high-level design. Okay, so in this reverse engineering, I said start from source code and all the files that are involved in a continuing project. Out of those source code, I can derive a class diagram, and it will be a mess, as you see here, because it is a lot of classes and files that are involved in a big project like Babulin. Okay, and so out of this mess, of classes and files, you can organize them into packages. And once you have the packages, group them into sets of packages. And we come up with components. Once we get the components, you relate it to the deployment diagram. Okay? So you can trace the origin of the source code and even the function all the way up to the deployment diagram. Okay? I hope that is clear because there is no chance anymore of repeating this lecture. As I said, this is the last day in our meeting, very last day. Okay, so with that is the end of the reverse engineering. Okay, software architecture and design. You have two methods of how to derive the software architecture and design. Now, doing this job of architecture, as I have said before, requires experience. It's not because I'm able to draw nice diagram that the design will work. If you are inexperienced, you never know whether your diagram will work or not. It could be a diagram that's good to frame and put on the wall. The value of your design is, will it work? Okay, that's why you are paid high salary, because the responsibility of having the software work or not depends on the architect. If the design is wrong, do you think the software will work? Okay, no way. That is why they are paid big bucks. And how do you achieve that level of expertise? It's through years of experience. And that is why when companies are looking for architects, they are looking for experience and skills. Okay? All right. Uh, I would like to open up this new paradigm that is going on in software development. It's called software-oriented software engineering. Okay, and in the early 1990s, uh, the computers can gain access to information from a remote server. I remember in the 1990s, there's a new browser that came out called Mosaic, and I was able to visit the museum at Louvre in France. Okay, I was so excited to look at those portraits, especially Mona Lisa. I see on my computer. So that was a great achievement that remote computers can access servers outside of your room or location. So the access is actually through a web browser, and but direct access to the information, you can view it, sure, but you cannot do anything else except for to view. That was during that time. The web browser allows you to look and admire the picture or graphics or data that is out there. So to allow access to the actual information, web services were developed. Okay, so you're able to access and update resources available on the web. Like for instance, you are in let me see, in Babylon, we access the teacher can access student records. Okay, and they can read the student grades and change the grade, right? So they're able to access and update, and that is what web services do for you. It provides web service to manipulate the data. You can put the data in, you can get the data out and manipulate it. So using web service, they want their information accessible to other programs, they can do so by defining what we call a web service interface. So the web service interface allows the user to actually access the information and manipulate it. Okay, and um, of course, when you are um, ordering a specific product on Amazon, you're given first, it allows you to do a search. Then after a search, it allows you to look at the information, and if you decide to buy it, then you get your credit card and pay it. And at the same time, since you ordered X number of items, their inventory will be reduced, right? So you're actually manipulating data in that in the Amazon inventory. You buy 3 items, then they will reduce 3 items from their inventory, and at the same time probably reorder items if their supplies are getting low. Okay, and then we have this software as a service, SaaS, means the functionality of a software can be done remotely over the web. Okay, so you are able to, I don't know, maybe software as a service, you want an operating system that you want to run on your computer, you can do so remotely. So even though you don't have that compiler or that operating platform in your computer, you can operate in that operating system if you like to. That's software as a service. Okay, software does not reside on your computer. The software resides remotely, and you are executing that software, and the result is being sent to you. But there is another paradigm, which is the purpose, or which is the basis of the service-oriented software engineering. The service-oriented systems, they are implemented using reusable service components. So the application can use that executable file in your application and it will execute. Okay? So it's like an executable application, executable module running in your application. And it can be called, and it will execute, will give you a result, and you move on. Okay, you're able to execute. Let me give you examples of this kind of a service that we have today. Okay, um, uh, let me let me show you this one first. When you are booking a flight, okay, booking a flight, you notice that after you book a flight, it asks you to book a hotel. Okay, so that is service that is executing in your application. Booking a flight also include booking a hotel at the same time. So you notice that when you are uh, buying a ticket, it also suggests, do you want hotel? Or you want a car, rental car, or a taxi? And it will kind of guess, oh, you're visiting, let's say you're visiting the Philippines, okay? And so it immediately calls this executable for famous islands in the Philippines where you have blue waters and white sand. Okay, so it will ask you, do you like to visit these places? And if you like to visit the place, okay, we'll book for you, and so on and so forth. So all of these service-oriented executables are part of the applications that we see today. Okay, and here in this example over here, this is a service-based in-car information system, and it consists of five component modules: the receiver, the transmitter, the user interface, the locator, and the radio. So let's say you are a tourist, you are renting a car, and you're driving all over Europe. Okay, you're visiting, I don't know, 5 to 6 countries, let's say, and the you have the locator module discovers where you are in Europe. The receiver is a radio. Um, the receiver receives signals, and it is um, uh, received by your radio, and you get information from the radio in the language of your what is your language that you are using. So it is a receiver, and there is a language info that you can receive. The transmitter here is used to report on your location, and a user interface if the driver wants to receive requests from a user. So it uses the UI, user interface, and the transmitter. And here are the services that is available for you, like weather info, facilities info, road traffic information, and service finds available services like gasoline or I don't know, bed and breakfast and so on. So what I'm saying is that this application that you have written employs service executable modules as part of your application. Okay, and it gives you information about that entity that you would like to do. And I don't know if you guys, the team who is assigned to Know and Vote, okay? And Know and Vote is an app that gives the user information about a candidate. So it is actually the application is asking for services from out there. So they're accessing, I don't know how many APIs you guys are accessing, but the APIs gives you news, gives you blogs, gives you Twitter. I don't know if they have included Twitter, but for now it's mostly news feed. And the news feed gives back information about the news, about a certain candidate position. Let us say in the George Floyd situation. And so opinions of the candidate about this controversy that happened is actually um, um, given to the user who would like to know that information. What does the candidate, a particular candidate, political candidate, feels about the George Floyd case? Okay, unfortunately, he has been mistreated, and of course, resulting in his death. Okay, so that information is extracted, the news reel is extracted, and information about what a candidate feels or opinion about that issue. And that issue is actually collected and given to the user about that issue. Okay? So what I'm saying here is that the software that you build today uh, can include service-oriented executable modules in your application. So it provides, so it is called, and then it returns a service. Okay, I think I have talked a lot. So let me end this lecture and wish you all a very good finals day requirements. Now, I am again repeating my what I said about your software architecture and design. The software architecture and design must follow either reverse engineering or forward engineering. If you don't follow the procedure of those two procedures I have mentioned, I will not give you additional points on your resubmitted software architecture and design. Okay, so good luck and um, be safe and healthy.